In the cold vacuum of space, a small, silent traveler drifts onward. Its mission was to explore the outer planets, but now it explores the universe itself. It left the world that built it, and it will outlive even the stars. Long after the sun has faded, and Earth is nothing more than a memory written in the dust of time, across a span of time deeper than history and distances greater than imagination, it will carry a fragment of who we were into a future none of us will ever witness. Voyager 1 sets out on a journey that would redefine exploration itself. It launches aboard a Titan 3D rocket just over 2 weeks after its twin, Voyager 2. The mission owes its existence to a rare alignment. The outer planets happened to line up in a way that let a spacecraft visit several worlds using gravity assists, a technique powerful enough to stretch a modest mission into a grand tour of the solar system. Voyager 1 carries a full array of instruments: cameras, spectrometers, magnetometers, plasma sensors, and detectors built to measure the energetic radiation filling the space between worlds. But bolted to the spacecraft is something arguably even more significant than the instruments themselves: a gold-plated copper disc known as the Voyager Golden Record. It holds images, sounds, greetings recorded in dozens of languages, music, and messages meant for whoever or whatever might one day come across it, along with instructions and a star map showing how to locate us using nearby pulsars. From day one, there was never a plan to bring it home. Voyager 1 was engineered to endure the vacuum, the cold, and the radiation long, enough to complete its work, and then to keep going for as long as the laws of physics would allow. Voyager 1 arrives at Jupiter, a world of chaos and lightning. Its cameras capture turbulence on a planetary scale, wind speeds reaching up to 1,500 kilometers per hour, storms forming and collapsing, cloud bands layering into intricate patterns, and the Great Red Spot, a storm 16,000 kilometers wide, large enough to swallow Earth whole. But the biggest surprise isn't on the planet itself. As the spacecraft passes Io, one of Jupiter's moons, scientists spot something extraordinary: active volcanic eruptions on a world beyond Earth. Some of the plumes tower 100 kilometers high, visible even from space. Voyager also examines Europa, Ganymede, and Callisto, Jupiter's other major moons. Then there's the side of Jupiter you can't see, its magnetosphere. Jupiter's magnetic field is immense, trapping charged particles and generating radiation belts far more intense than anything found near Earth. Voyager's instruments measure those particles firsthand, mapping out a space environment harsh enough to damage electronics. After the flyby, Jupiter offers Voyager exactly what it needs next: a gravity assist. The spacecraft swings past the planet, borrows a small sliver of Jupiter's orbital energy, and converts it into extra speed and a new outbound trajectory. Saturn comes into view as a pale globe wrapped in rings. Seen from Earth, those rings look like a single smooth, bright band. Up close, Voyager 1 reveals their true structure: countless individual ringlets, gaps, waves, and sharp edges, each carved by gravity and the pull of nearby moons. The rings themselves are colossal, made up mostly of water ice particles ranging from tiny grains to boulder-sized chunks, spread across hundreds of thousands of kilometers. Voyager also studies Saturn's magnetosphere and the moons orbiting within it. Some of those moons act almost like sculptures, keeping ring edges sharp and carving out gaps, while others show surfaces shaped by impacts and internal geological activity. But the main target here is Titan. Titan is larger than Mercury and shrouded in a thick atmosphere, the only moon in the solar system with an atmosphere dense enough to completely hide its surface. That atmosphere is mostly nitrogen, laced with methane and complex hydrocarbons, and its surface pressure runs about 1.5 times Earth's. Titan matters because an atmosphere this dense is essentially chemistry in motion. Sunlight and energetic particles break molecules apart and reassemble them into heavier compounds, which, in the frigid outer solar system, can form hazes, rain, and deposits on the surface. Voyager sweeps past Titan at close range, bending its trajectory and setting it on a path that leads straight out of the solar system. In 1990, Voyager turns its camera back toward the inner solar system one final time. From nearly 6 billion kilometers away, it captures a family portrait, a mosaic of the planets. In one frame, Earth shows up as nothing more than a tiny point of light, the pale blue dot. Every human story, every dream, every thought, compressed into a single pixel. After that portrait, its cameras are powered down to conserve energy. From here on, it's headed toward the edge of interstellar space at roughly 17 kilometers per second. One last boundary remains: the heliopause, the region where the pressure of the solar wind is matched by the pressure of the interstellar medium beyond it. Crossing it isn't like passing through a checkpoint. Voyager doesn't see the transition, it only detects it. As it nears the heliopause, the particle environment around it shifts. Instruments register a sharp drop in particles originating from inside the heliosphere, alongside a sharp rise in cosmic rays arriving from outside it. On August 25th, 2012, Voyager crosses the heliopause and enters interstellar space, the vast region between the stars. By late 2026, Voyager reaches a distance of 25.9 billion kilometers from Earth, becoming the first human-made object to travel a full light day away. Light now takes an entire day to make the one-way trip between Earth and the spacecraft. A command sent today doesn't reach it until tomorrow, and any reply arrives the day after that. At the same time, Voyager's power supply keeps shrinking. The radioisotope thermoelectric generators that keep it running lose output steadily over time, and across the decades, that decline forces engineers to shut down its systems one by one, just to keep it operating on whatever power remains. Voyager has now been traveling for 60 years. Its power has dwindled to a fraction of what it once was, and most of its instruments have gone silent. NASA currently expects it could stay within range of the Deep Space Network's communications until roughly this point, though well before that final loss of contact. Its scientific output will already have narrowed down to whatever its last working instrument can still measure. From Earth, it won't look like it's dying. It will simply stop answering. At that point, Voyager becomes what it has effectively already been for most of its journey. A small traveler adrift in deep space, moving forward, with no way of knowing whether anyone is still listening. Roughly 40,000 years from now, Voyager will pass relatively close to another star, Gliese 445. Though close still means a closest approach of about 1.7 light years away. The gravity assists at Jupiter and Saturn reshaped its path through the solar system, but out beyond the planets, there are no more convenient boosts to be had. Between the stars, distances are so vast that even a fast-moving spacecraft effectively crawls. By this point, Voyager's radio has long gone quiet. No one is tracking it day to day anymore. No one alive remembers the engineers who built it. It has become a relic of a civilization that may no longer even exist. By roughly 3 to 4 billion years from now, the scope of the story shifts entirely. Voyager 1 is no longer meaningfully tied to the solar system at all. It's simply somewhere out in the Milky Way, its exact position impossible to pin down with any certainty. But the galaxy around it isn't standing still. The Andromeda Galaxy, our nearest large galactic neighbor, has been drawing closer for billions of years, and eventually the gap closes enough for it to dominate the sky entirely. When the two galaxies begin their encounter, Andromeda and the Milky Way will pass through one another as gravity reshapes everything in sight, eventually merging into a single galaxy. From wherever Voyager happens to be, it would be an extraordinary spectacle, one unfolding over billions of years. The universe today is about 13.8 billion years old. 10 trillion years from now is roughly 1,000 times longer than that. By then, the familiar age of bright, massive stars will be long finished. Only the smallest red dwarfs will still be shining, burning through their fuel so slowly that they can last for trillions of years, though even they don't last forever. As usable hydrogen runs out and star formation grinds to a halt, galaxies become little more than collections of stellar remnants. The night sky thins out. The universe grows quieter. If Voyager has somehow survived this long, it will by then be older than nearly every active star that once illuminated the Milky Way. Beyond the age of stars, everything becomes theoretical. One possibility is proton decay, ordinary matter slowly breaking down as atoms themselves come apart, with everything that exists eventually dissolving into lighter particles. If Voyager endures long enough, the universe itself will begin to erase it. It traveled farther than anyone ever dared imagine. And its message endures that somewhere in the vastness of the cosmos, life looked up and reached out.